Alright, so in this section we're going to do division of polynomials, and I bet you would kind of expected that since in the previous sections we did addition, subtraction, and multiplication of polynomials. So the first objective here is to divide a polynomial by a monomial. So we're just going to divide each term of the polynomial by the monomial. So just make sure that this denominator only has one term in it. So we have 12 plus 32 over 4. So we're going to say 12 over 4 plus 32 over 4. So 12 over 4 is, 3. And 32 over 4 is 8. And 3 plus 8 is 11. Of course, there are other ways to do this, but we are using the rules that they said to use in the box. Alright, so please keep that in mind, that it's not like there aren't other ways to do this. We're just doing it one certain way in this section. Alright, so let's look at B. It's 3h to the 4th minus 6h to the 3rd plus 10h minus 5 all over 3h squared. This is a monomial again. So I'm going to divide each term individually by this monomial. So this is actually kind of a lot of writing, but I hope that all of you are really enjoying this. Alright, so let's simplify each term as much as we can. We can cancel these 3's, and then h to the 4th over h squared is h to the 2nd. 6 over 3 is 2, so minus 2h. And then 10 over 3 cannot really be simplified, so I'm going to leave it as 10 over 3, and then cancel out an h, so it's actually 10 over 3h. And then the same thing over here. Nothing can be simplified, so I leave it as 5 over 3h squared. Alright, so with that being said, you can see that there are no like terms, so I really would just leave the final answer looking like that, as awkward as it might look. So, again, if you have any questions, feel free to email me or bring them to class. There are a few more here for you to try, but we're going to now divide a polynomial by a binomial. So, when we divide by a binomial, these are going to be the harder ones. These are the ones where we're going to use long division. I know. Alright, so this is going to go just like long division normally would. We're going to start at the beginning, the 6x squared and the 2x, and divide these out. So I'm left with 3x. Now, because this is a 3x, I'm going to write it right above the term that has an x in it, which is this minus 5x. Then I'm going to multiply that 3x I just found times this 2x plus 3 over here. And this is where I needed the multiplication. So 6x squared plus 9x, that's going to go under here. But because what I need to do is subtract, I'm going to change both of these signs. So I have 6 minus 6 is 0. And negative 5 minus 9 is actually minus 14. And then bring down the minus 21. And then I start over from the beginning again. I take this minus 14x and this 2x right here. So minus 14x over 2x is equal to negative 7. So minus 7, and then I distribute this times the 2x plus 3. So minus 7 times 2x plus 3 is minus 14x minus 21. And then remember I have to subtract, so I change the signs. So this was minus, so it become plus, and that was minus, so it become plus. So minus 14 plus 14, 0, minus 21 plus 21, 0. So that means my remainder is 0. So the answer to this is just 3x minus 7, what I had up here. Alright, so this might take a little bit of getting used to, but I have great news. That wasn't the only one of these that we're going to do. I would like to show you another one here. So 5x squared plus 21x plus 9 divided by a binomial x plus 4. So again, because it's a binomial and not a monomial, we're going to need long division. Then I start at the beginning and divide 5x squared over x, so that simplifies to 5x, and I want to align the x's on top of each other, and then I distribute 5x times x plus 4 is, what is it? Oh, bah humbug. 5x squared plus 20x, so 5x squared plus 20x. Now remember, I need to subtract, so that becomes minus and minus, so 5 minus 5, 0. 21 minus 20 is just 1, so this is 1x plus 9, or just x plus 9. Then again, I start at the beginning. We have x over x is 1, so this will be plus 1. Distribute, 1 times x plus 4 is just x plus 4. Then I need to make sure that I remember to subtract, so minus, so x minus x, 0, 9 minus 4, 5, so the remainder is actually 5 now. But what is the remainder out of? The remainder is out of x plus 4. So this ends up being 5x plus 1 plus 5 over x plus 4. Just like you normally would have a remainder that's a fraction or a decimal in the regular division, you could have it here as well. Alright, so let's look at page 161. So check division of polynomial problems. So we're going to divide and check it this time. So here we have a binomial in the denominator again, so negative 3x minus 1. Now, this is going to be a little bit harder because these are not in descending order, so I would write the negative 12x squared plus 11x plus 11 in this order because I want descending order, so that it will be easier for me to do this division here. Alright, please keep that in mind. So if I start out using the negative 12x squared over negative 3x, that ends up being 4x, and I'm going to write that right above the 11x. And then, let's see, I have to do the 4x and distribute it to the negative 3x minus 1. And that will give me, oh no, why can't I see that 1 there? Sorry about that. That will give me negative 12x squared plus 4, sorry, minus. That's why I couldn't see it. I could not see that for some reason. Minus 4x. So here is my minus 12x squared minus 4x. Remember that I need to subtract, so I need to change the signs. Plus, so that cancels. Negative 12 plus 12 is 0. And 11 plus 4 is 15, so I have 15x and bring down the 11. Then I start at the beginning, 15x divided by negative 3x, so 15x over negative 3x gives me a negative 5. And then I distribute the negative 5 times the negative 3x minus 1, so I'm left with 15x plus 5. 15x plus 5. So then I need to remember that I should subtract. So minus 15 minus 15 is 0. 11 minus 5 is 6. So my remainder is 6 out of a negative 3x minus 1. So this is 4x minus 5 plus 6 over a negative 3x minus 1. Now, if you look at the rules here, and you know what, I'm going to scroll back up. This is going to look a little bit awkward, but I want to scroll up. you're going to take the divisor times the quotient plus the remainder, and then that should equal the dividend. Alright, so the divisor... I didn't. I want you to say that. Divisor times the quotient plus the remainder equals the dividend. So, what we're going to do here is we're going to do exactly what it said. The divisor times the quotient, so the negative 3x minus 1 times the quotient that we found, 4x minus 5 plus the remainder of 6 should equal the original numerator. So let's distribute here. So negative 3x times 4x minus 5 gives me negative 12x squared plus 15x. Then we have the negative 1 times the 4x minus 5, which is negative 4x plus 5. And then we have the plus 6 at the end. So we combine the like terms, and we are indeed left with negative 12x squared plus 11x plus 11. Kaboom! Alright, we just verified that. We just checked it out. I'm very excited about this. I could not even be more happy if I want it to be. B. Where is B at? 12x to the third plus 11x squared minus 17x minus 12 over 4x plus 5. So here is a binomial in the denominator. So I have to set it up as a long division problem again. And hopefully you don't think long division problems are as long as they were when you first started them. So I always have to again start at the beginning. 12x to the third over 4x, that gives me a 3x squared, and I'm going to align that right above the x squared term before I distribute. So 3x squared times 4x plus 5 is 12x to the third plus 15x squared. Now, what I do next is I actually subtract or change the signs here, so I'm left with these. 12 minus 12 is 0, canceling, and 11 minus 15 is negative 4, so negative 4x squared, bring down everything else, and then I start at the beginning again. Again, this might seem very tedious, but guess what it is? I'm not going to lie to you. This is flat out tedious, and no one's going to do it for you. You have to do this for yourself. Actually, you might be able to hire my grandma. She might do it for you. Alright, so let's distribute this negative x. So negative 4x squared minus 5x. So here we have negative 4x squared minus 5x. Then we need to remember to subtract, so we're going to change this to a plus. I use the same color. I'm colorblind, and I can even tell that doesn't even make sense. So let's make this a plus there, and this a plus. So negative 4 plus 4, 0, negative 17 plus 5, negative 12. So negative 12x minus 12. Then I'm going to start doing this all over again. So negative 12x over 4x will be negative 3. So negative 3 times the, the 4x plus 5. That is negative 12x minus 15. And then remember, I have to subtract. So I have to change this to a plus, and that's to a plus. Negative 12 plus 12 is 0. Negative 12 plus 15 is a 3. So it's a remainder of 3 out of 4x plus 5. So let's check this again. It is the quotient 4x, the quotient, the 3x squared minus x minus 3 times the divisor, 4x plus 5, plus the remainder of 3. Let's try to distribute this. We're having a jolly good time here, I can tell. At least I am. 12x to the third minus 4x squared minus 12x. Then distribute the 5 plus 15x squared minus 5x minus 15, and then we still have the plus 3 at the end. And then there's just a lot of combining of the like terms. So we have, what do we have? 12x to the third minus 4 plus 15 is 11, so plus 11x squared minus 12 minus 5 is minus 17, so minus 17x, and then minus 15 plus 3 is minus 12, and cha-ching, you do have the same thing as you started with in the numerator. Alright, so again, if you have any questions, please make sure that you email me or ask them in class. But we're going to, let's see, I did one earlier where I wrote it in descending order, if you don't remember. So what I will do for all of you is, if you bring in example A to class on Wednesday, complete it, I will give you 5 points extra credit. Okay? But it's due Wednesday. Due Wednesday only. It's a one-day special. And which Wednesday am I talking about? Wednesday, April... it better be April 6th. If it's not, I'm making this up, and it better be in the year 2016. Alright, there we go. Alright, so let's look at example B. I will do example B though, because it's a little bit more difficult. So we have a binomial in the denominator, so we have 3m minus 2 goes into, now I'm going to write this in descending order, 9m to the 4th, and then 5m squared minus 15, but we don't have any cubed terms here, so we have 0m cubed, and we have 0m. I need to make sure that all of the powers are here, and you will see in the next step why. Because if I have 9m to the 4th over 3m, the first step that I normally would do, what I have is 3m to the 3rd. But the 3m to the 3rd has to go right above the m to the 3rd term. But there wasn't one. There were 0m to the 3rd. Alright, then I take the 3m to the 3rd times the 3m minus 2. And I get 9m to the 4th minus 6m to the 3rd. So here we are, 9m to the 4th minus 6m to the 3rd. Remember, I need to subtract. So subtract, and then that changed to adding. So 9 minus 9 is 0. 0 plus 6 is 6. And then bring everything else down. 5m squared plus 0m minus 15. Now I start from the beginning. 6m to the 3rd divided by 3m. That gives me a 2m squared. And I multiply the 2m squared times the 3m minus 2 to get 6m to the 3rd minus 4m squared. Now, what I do, I need to remember to subtract, so I change the signs. So 6 minus 6, 0, 5 plus 4, 9, so 9m squared plus 0m minus 15. Remember to bring everything down. Then I start again. 9m squared divided by 3m. Oh no, where can I write this? 9m squared divided by 3m is 3m. And then I have to do 3m times the 3m minus 2, which is 9m squared minus 6m. So the 3, I haven't been writing these down here, have I? Sorry. I'm so sorry. I didn't even realize I didn't write any of them at the top. Alright, so now I have 9m squared minus 6m. I need to actually change the sign, so minus plus, so 9 minus 9 is 0. 0 plus 6 is 6, so 6m, and bring down the 15. Then I start over again. Whew. 6m over 3m is 2, so plus 2, and then 2 times the 3m minus 2 is actually my 6m minus 4. And then I change the signs just like I have been. Minus plus, so negative 15 plus 4 is minus 11. So the remainder is 11 out of 3m minus 2. Kaboom! I hope that all of you really enjoyed this. And that is the end of section 4.6.